Continuing our series, we're going into TypeScript functions with functions. Woohoo! Okay, let's get to it.
Episode 3 of No BSTS, and in this one, we're going to look at functions that take functions or create functions. Now, this is our video series where we do small 5 to 15 minute videos on TypeScript, no BS, and you can learn at your own speed. It's free. Let's jump right into it. Picking up where we left off, we've got our functions.ts, but I'm really not going to use that one here. We'll make a new one called funcs and funcs.ts. And so let's say you make a function and you want it to support a callback. So in this case, for example, you want a print to file function. That takes some text and then also takes a callback. And doesn't return anything, so it'll do a void. So now we want to go and print out that text. And now we want to call that callback. So how do we define that? Well, let's see if Command K, Command I gives us any hinting there. Nope, it doesn't. It just says it's any. So what we can do is we can use the colon, and then we do what looks like a function, but is in turn actually a type specification. So you give it the open and close parens, and then you give it the return type. If you want to have some additional values in there, you can just put, like, for example, v is a number, and then we take a number. So you can pretty much define it just as you would any other function. And let's try that. Let's create an array mutation function that takes an array of numbers. And then it's going to take a function that is given each number and returns a new number. So for example, call mutate. It's going to be a function. It's going to take a number and it's going to return a number. And this function is going to return a set of numbers on its own. And now how do we do this? Well, honestly, this is just map. So let's just do numbers.map and then give it that mutate function. All right, let's give it a try here, console.log. We'll give it our array mutate. We'll give it an array of 1, 2, and 3. And let's see, so it's automatically hinting us that we need a function here, and that function takes a number and it returns a number. So let's do that. And let's just multiply it by 10. Okay, let's run it in console log. Again, we'll use TS node, and we're calling this one funcs and funcs. And there you go. 1, 2, 3 becomes 10, 20, 30. Change that 20 there. Run it again. 10, 230. Excellent. Cool. But this is a little bit hard to read, at least for me. So I'm going to define this as a type. Now, anything that is after that colon is a potential type specification that you can share with other things. So I'm going to grab this, copy it, and then create a new one called type mutation function. And then in this case, unlike interface, you have to use equals and then paste that. And there you go. Now copy that and paste that in there. And I think that just reads a little nicer. Now you can also, if you like, you can export this mutation function as well. And that way, when somebody's creating a function, let's go here and create a potential mutation function. So my new mutate function, and it'll just give it the type of mutation function. And it doesn't qualify yet because I haven't implemented it. So let's go over here and we're going to say we want a value, and that value is a string, and then it's going to return a string, and there you go. And it's like, wait a second, hold up. That's not right, because the type of a function that takes a string and returns a string is not assignable to a type mutation function. All right, which is very true. So this needs to be a number. which is still not right because now we're exporting
Say
a
what? Let's do that
value,
again.
and it doesn't qualify yet because I haven't implemented it. So let's go over here and we're going to say we want a value, and that value is a string, and then it's going to return a string, and there you go. And it's like, wait a second, hold up. That's not right because the type of a function that takes a string and returns a string is not assignable to a type mutation function.
Oh, okay, that's where he's reading this from. Okay, from next. Like, what is he saying? Okay. All right, so mutate and I wonder if I can do this. Mutate mutation function. Okay, that's that guy. Mutation function array mutate. Yeah, so what's going on here with this? Can you do this? Will that grab this and right, and just kind of let that do this? Now prettier may have its own feelings. Yeah, it's never used. Like, where was this used before in this? Because that's sitting here, but he's never used. So let's see if prettier adjusts this at all. Huh, no, okay, it lets me do that. Okay.
All right, which is very true. So this needs to be a number, which is still not right because now we're exporting a string. And now we'll do times 100 or whatever we want in there. And now we're fine. My new mutation function qualifies as a mutation function as defined by this type. Okay, so how about functions that return functions? So let's make a classic JavaScript closure. Call it create adder. And it's going to take a number. And it's going to return a new function, which takes a number and then adds the original number, or captured number in this case, to the number that's being brought in. And so how do you use a function like this? Well, I'm going to say add 1, for example, is going to be create adder with 1. And then any time that I console log add 1 plus some new number, say 55, then I run that. Let's just bring that up so we can see it. Now we're going to get 56 because we captured this 1 there, and add 1 is a new function that will go and add 1 to any value that comes in. It's really pretty cool. That's basically the basic mechanics of JavaScript and TypeScript closures. Okay, but now how do we define the output type of this? So let's do Command K, Command I, our old friend. And hey, nice. It's actually showing us the complete thing here, the complete definition. So let's go copy and paste that. And there you go. But if that, again, kind of reads a little funky, we can actually, again, go and copy that. And actually, look, it's the same exact thing as mutation function. I'll just make a new one. Let's see, call it an adder function or something like that. Adder function. And there we go. Nice.
To make it cleaner.
Excellent. Okay, cool.
All right, hang on. Let's run this. Make sure, because like what? Because what would we do up here with that? That was like arbitrary or something. Because that's not even used anywhere. What are we doing? Yep, and ooh, are we still in the wait? Where are we at? Close. Okay, that was nothing. All right, so XTS node funcs. Let's see that. No. Okay, there we go. All right, groovy. All right, and okay.
Cool. Now, it really is worth getting to be familiar with functions that take functions and functions that return functions, particularly because there's such a big hype around functional programming when it comes to JavaScript, TypeScript, everything else, a lot of our frameworks use functions, calling functions, returning functions, and a lot of that. So being familiar with
Yep,
this syntax is really important. And as we get into generics, it'll be even
this
more
is true.
important. Of course, in the meantime, feel free to like and share this video with your friends. Hit that subscribe button if you haven't already. Click on that bell and you'll be notified anytime a new one of these videos comes.
Yep. So yeah. Oh yeah. I forgot to say this in the very first video. Jack is a lead engineer. He's a more advanced than I am. I'll give him credit there. Credit is due. It's better than I am than this. So I am going and I'm enjoying. And he's put this whole cool YouTube channel where he's got lots of different lessons on various stuff, and I'm really enjoying. I really am digging his TypeScript stuff here. So that is the end of part 3. Next up is part 4, or function overloading. So let's get into that right after this. So let me go ahead and get this all ready to go. It's the end of this one, and see you in the next one.